1D Kinematics in 5 minutes, part 2. Hi, I'm Shankar Krishna, an engineer turned teacher who has helped over 1,000 students unlock their potential in science and math. I'm here to make these lessons not just easy, but exciting for you. In today's video, we're going to be exploring a little bit more details of one-dimensional motion. So starting off with motion equations, falling objects, and graphical analysis. What do motion equations do? Why do we need these equations? So these equations helps us to understand simple motions like a ball rolling down a surface to complex motions like firing a rocket into the sky. These are a set of equations which relates certain physical quantities like velocity, displacement, acceleration, and time. Now let's see what are these equations and how do they relate them. These 5 equations relate these physical quantities such as velocity, acceleration, displacement, and time with each other. Not every equation is able to relate to all of them, but some equations do. Now when we take a look at these notations, each of them represent a different thing. For example, V0 is going to be the initial velocity, while V being the final velocity of an object. A being the acceleration, T being the time, obviously. Now the most thing that every student gets confused about is these X and X0. X0 mentions the initial position while X represents the final position of an object. So keeping that in mind, when we need to write displacement, which happens to be the change in position, which is delta X, is given by the final position minus the initial position. Now this is an important expression because at times you are given the displacement, not the individual position of an object. So pay attention to that while you're reading the questions. One thing to remember about all of these equations is that the acceleration here is constant. These equations are not valid for a motion which has variable acceleration. These are constant accelerations. Now, why do I need to study about objects that's falling? Seems to be nothing that I should be concerned about, right? Studying about falling objects has numerous applications, like calculating what is the safest height a roller coaster can go to experience something closer to a free fall while coming down. And also it can help us calculate what is going to be the impact of an asteroid that is plummeting into Earth. Now, while studying about falling objects, the most pressing question is that why do objects of different masses fall at different rate? The answer to that is very simple: air resistance and friction. Now, if these things are negligible, like we would see in most of our questions, then all objects would fall under the same rate. If you want to see cool experiments on that concept, comment down below and we'll get that started. The key thing to remember about while studying falling objects is that all of these objects fall with the same constant acceleration and they are independent of their masses. Let's move to the next one. So how do we calculate the different parameters of an object that's falling freely under gravity? Well, we refer back to the same equations that we just learned. Now, when you notice these equations, all of them have an acceleration component. And since these objects are falling freely under the influence of gravity, you just got to replace the acceleration with acceleration due to gravity, which seems to have different values, but occasionally to be taken as g equals a negative 9.8 meters per second squared. Now, what does the negative value imply? It means that it's following a downward direction, and according to the Cartesian sign convention, the negative sign is always associated with something either moving downwards or left on a Cartesian sign coordinate system. Another important thing to keep in mind while preparing for AP1 is that the College Board accepts g as 10 meters per second squared. So unless it's specified otherwise, I would recommend that you take g as 10 meters per second squared for all of your calculations. So how does this help in finding out the parameters of these objects that's falling freely under the gravity? So what do we do with this new information? We replace a in every one of this equation with g, especially negative g, and then we get a new set of equations. I highly encourage you to try this out and write those equations even though you have an access to a formula sheet for your AP exam. The world around us is visual, and hence you can't expect everything to be in the form of a sentence. And graphs are a great way to visualize data. A graph is usually plotted between two physical quantities where one of them becomes something called as a dependent variable while the other becomes something called as an independent variable. In AP Physics, we deal with 3 different graphs which has relation between different physical quantities. Our first graph is going to be the position time graph, where the relationship is between position and time and how does position vary with respect to time. The second graph talks about the velocity time relation. How does velocity is changing with respect to time? And the third one is how acceleration is changing with respect to time. When you look at these graphs, you notice that these graphs do not have the same shapes in every single instance, and you might get a combination of these graphs in questions. So how do you go about understanding this? Since AP Physics 1 is algebra based, you would most certainly have a straight line or a very simple curved graph which will enable you to draw a straight line by drawing a tangent at a certain point. Once you have a straight line, you can find the slope of that straight line using multiple formulas, and one of the common ones being the rise over the run. Each of these graphs have a different slope value, and they also happen to have an area under the curve that's there on the graphs. The slope of position time graph gives you velocity. The slope of velocity time graph gives you acceleration. The area under velocity time graph gives you displacement, and the area under acceleration time graph gives you change in velocity. And there you go, most important concepts in a very short amount of time. The link to this lecture notes is in the description below. Check that out. If you found this video helpful, make sure to share, like, and subscribe to the channel. I'll see you in a different video.